Hi everyone, let's discuss exercise question 3.12. A ball is dropped from a height of 90 meter on a floor. At each collision with the floor, the ball loses 1/10 of its speed. Plot the speed time graph of its motion between t is equal to 0 to t is equal to 12 seconds. So just see this one. A ball is released from a particular height. Ball will come from rest and it will come down with an increasing speed, and each time when it bounces, its speed decreases by 1/10. So this motion we have to draw in terms of speed time graph from the time is equal to 0 to 12 seconds. So let's discuss this question here. A ball is releasing from the top. Okay. So what is the initial velocity here? Initial velocity while we are dropping it is equal to 0. It is now falling under gravity with a height of 90 meter. The height is here 90 meter. So from the 90 meter it is falling down. What is the time taken to reach this ball exactly just before hitting the ground? Correct? So what is the time formula we can calculate here? The time while we are dropping an object, we can write here square root of 2h divided by g. Square root of 2h divided by g. So here what is the time taken? Root of 2 into height is here 90 meter divided by g. G is equal to 9.8 meter per second square. So how much time is taking to reach this ball exactly at the bottom? The time we can approximately calculate this as 4.3 seconds. So just imagine a ball is released from the top. That means speed is 0 now. Initial velocity is 0 here. While it is coming down, what will happen? The speed increases linearly with the time. Till what time? 4.3 seconds. Now at that same moment, 4.3 seconds, what will happen? The ball will hit the ground, and at the same moment it will go up. But while it is going up, its speed now decreases by 1/10 of its initial speed. So what is the speed just before hitting the ground? So we can use the formula here. V is equal to u plus at, equations of motion. Here it becomes what? V is equal to u plus gt, because the object is now falling down. So we can take it as what? V is equal to u plus gt. Here what is the u value? Here u value is equal to 0. While we are dropping an object, u is equal to 0. So v is equal to gt. V is equal to gt. Or we can write here what? The final velocity v is equal to 9.8 into how much time is taking to reach at the bottom? 4.3 seconds. So what is the final speed when it is just before hitting the ground? If you calculate this value, you will be getting it is approximately equal to 42 meter per second. Approximately 42 meter per second is the speed just before hitting the ground. Correct? So we can start from here. T is equal to 0. Starting from t is equal to 0 till t is equal to 4.3 seconds. It is now coming or falling down, and finally the final velocity just before hitting the ground is equal to what? 42 meter per second. Now you just imagine after hitting the ground, what will happen after each collision? What will happen its velocity decreases by 1/10. So just before hitting the ground, it is velocity is equal to 42 meter per second. But when it is hitting and going upward, it loses its speed by 1/10. That is equal to how much speed is now decreases? That is equal to 4.2 meter per second. The speed decreases. So while the ball is hitting the ground and again it is going up, what is the speed while it is moving upward? Speed while it moving upward. Okay. Moving upward after hitting the ground. That is equal to what? What is initial velocity? 42 meter per second minus, now how much it is decreased here, 4.2 meter per second it is decreased. So that is equal to approximately, we can write here 37.8 meter per second is the speed when the ball is now going upward. See, the ball is coming down, hit the ground. Just before hitting the ground, the velocity become 42 meter per second, and after that it is going upward by reducing 1/10 of speed. So here the ball is going up with a speed of what, 37.8 meter per second. Now again the ball will go up, correct? It won't reach exactly at this point, it may reach somewhere here because 1/10 of speed is decreased here. Now we have to calculate this time, how much time will be taking for ascending. If you calculate the time of ascent, definitely the same time will take once again to come down, and that is, we have already discussed that one, that is called what, time of descent. So let's draw this speed time graph by using these calculations. So we can draw the graph here. Just draw the x-axis and y-axis. Along the x-axis we can take the time, okay? Along the y-axis you can take the speed. We are denoting it as v in meter per second. Time is in second. So first case, dropping from highest point, when it will hit the ground, just before hitting the ground, nearly we have calculated as 4.3 second. So see this one, somewhere here we have to draw 4.3 second starting from origin. So we can draw the graph like this. See this one, starting from 0, okay? When it will reach the ground here, nearly when the time is equal to 4.2 second. So this is approximately we are drawing here till 4.2 second it will reach the ground with a maximum velocity of what, 42 meter per second. So you can see here approximately what, 42 meter per second. Okay. Now what we have discussed, the 1/10 of its velocity decreases, or 1/10 of its speed decreases, correct? 1/10 of speed decreases means what is the initial velocity now here while it is going upward? U is equal to 37.8 meter per second. That's what we have discussed just now. Now it is going upward with an initial speed of 37.8 meter per second. Ball will come down and hit the ground. Velocity was 42 meter per second. Again, while it is going upward, the ball is now going upward with an initial velocity of 37.8 meter per second, correct? 37.8 meter per second. The ball will go up once again. At one particular point, again the speed come to 0, right? Speed come to 0. Again it will come down and it will hit, and again this process will continue, okay? So we have to draw the speed time graph until the 12th second, okay? So we have drawn till 4.3 second. Now you have to calculate here how much time it will take to ascend, correct? Time of ascent. So as we already learned that formula here, time of ascent is equal to u divided by g. So in this case, while the ball is going up, what is the u here? U is given the 37.8 meter per second divided by 9.8 meter per second square, which is equal to approximately 3.9 second. Okay, so it is now, the ball is now ascending for 3.9 seconds. So what is the total time now here? The total time now is equal to, first of all, 4.3 second. Now it's again going up for some time, that is 3.9 second, which is equal to approximately how much it will come now here? That is equal to 8.2 second. Now you have to draw a graph in the speed time graph. What is actually happening here? Speed is now, initial speed is 37.8 meter per second. When it is going and reaching at this point, at exactly at the highest point, what is the speed? It come to 0. So we can draw a graph from 4.3 second itself. So just before hitting the ground or hitting the ground, at the same moment it is going up also, right? So same moment what these all things are happening. So speed now decreases to what? 37.8 meter per second. So somewhere here. And after that, what do you have to draw here? For till 8.2 second. Till 8.2 second, what is happening? The speed is linearly decreases because the ball is now going upward. So you can draw the graph like this. See this one? When the ball is going upward, the initial speed is now what? 37.8 meter per second. From the speed is linearly decreases while the ball is going upward. At exactly 8.2 second, here you can see the velocity become or the speed become 0. That means now the ball is reached at the highest point. Now let's calculate how much time it will take to reach once again at the bottom. So as we already learned that one word, time of ascent is equal to time of descent. Here what is the time of ascent? We have already calculated what? 3.9. So next 3.9 second, the ball is coming down with an increasing speed or linearly the speed is increasing. So next 3.9 second means once again while it is coming down, what is the total time taken here? Total time taken is equal to 8.2 second plus once again it is coming downward with the time what? 3.9 second. So how much, what is the time now here? So what is the total time once again here? If you calculate this one, you will get 12.1 second. So what is this process happening here? Ball is coming from the top, that is speed is equal to 0. Now it is coming downward with an increasing speed or linearly the speed is increasing for how much time? 3.9 second more. So already the graph is drawn till 8.2 second, right? So one more 3.9 second. It is now 12.1 second. So the question is asking for you draw the speed time graph for till what? T is equal to 0 to 12 second, right? So this much is now is enough. So how to draw this graph here? While it is coming downward, speed is increasing. So slope must be what? Positive. So you see this graph now here. The graph here from 8.2 second till approximately 12.1 second, the speed is increasing. Speed is increasing till how much? 37.8 meter per second. Because the projection speed as well as when it is just before hitting the ground, the speed will be what? Equal 37.8 only. And here once again it will decreases and it will continue. So we have to draw till 12 second. Okay, I hope you understood this one. Thank you all of you.